Asia AGSSA President and the President of Indian Geotechnical Society, Dr. Anil Joseph, AGSSA Vice President Engineer Sohail Kibriya, Chair of Geomanu 2027 and General Secretary of AGSSA, Dr. Mandip Subedi, distinguished speakers of today's webinar, Professor Dr. Marwan Al-Zaili from UAE and Dr. Mohan Prasad Acharya from Nepal, respective EC members from both host organizations, esteemed participants from different parts of the world to this special webinar, jointly organized by NGS and ISSMG UAE Member Society. Nepal Geotechnical Society, NGS, has been conducting a joint webinar series since 2024 with geotechnical member societies across South Asia following the formation of AGSSA. The first webinar in this series was successfully organized in collaboration with IGS, and following the success of inaugural webinar organized jointly with IGS, this initiative has continued to strengthen knowledge sharing and exchange among geotechnical societies across the region. So last month only, we successfully hosted another webinar in partnership with the Sri Lankan Geotechnical Society, SLGS. So building on this momentum, we are delighted to organize today's joint webinar with ISSMGE UAE Member Society. Before we proceed, I would like to introduce today's program and speakers briefly. We will be here for nearly 1.5 hours. So this webinar is composed of welcome remarks and introduction to NGS by General Secretary of NGS, opening remarks by Dr. Anil Joseph, 2 invited presentations, Q&A, invitation from Chair of Geomanu 2027, and finally concluding remarks and introduction to ISSMG UAE Member Society and GeoSOE. With this note, now I would like to request Engineer Kalpana Adhikari, current General Secretary of Nepal Geotechnical Society, to deliver her welcome remarks and introduction to NGS. Over to you, ma'am.
Thank you, Razan. Namaskar, everyone, and a very warm welcome to all of you. On behalf of Nepal Geotechnical Society, NGS, I'd like to welcome you all to today's webinar, jointly organized by NGS and ISSMG UAE chapter. We are honored to have with us, Razan also already mentioned, Dr. Anil Joseph, the President of AGSSA, Engineer Sohail Kibriya, the Vice President of AGSSA, and our distinguished speakers, Professor Marwan Al-Zaili and Dr. Mohan Prasad Acharya, and all the participants joining from Nepal, UAE, and all around the world. Welcome once again. This moment, let me take opportunity to briefly introduce the Nepal Geotechnical Society. NGS is a proud member society of ISSMG, and we have been actively connected with the international geotechnical community for more than 3 decades. We conduct national and international conferences, webinars, lecture series on regular basis, and also try to connect with other geotechnical societies as well. And today's webinar is also one of the examples of international collaboration among geotechnical professionals. And we are very glad to collaborate with ISSMG UAE chapter. We all know in just few decades, UAE has become a global model of development, and it's been a model of engineering excellence, and many engineers from all around the world are attracted, and it has taken the attention. So Nepal can learn so many things from UAE. There is so much to learn from this, from your experiences. And finally, I believe this joint webinar is an excellent opportunity for us to share knowledge, learn from one another, and more than that, strengthen our relationship between the professional communities. So I'd like to thank ISSMG UAE chapter for this collaboration and support in making this event possible. I'm sure and I'm very hopeful that today's session will be very insightful and fruitful for all of us. So Thank you once again for joining us, and I wish I wish you all an engaging and productive webinar. Welcome and thank you. Namaste.
Thank you very much, Engineer Adhikari ma'am, for your warm welcome remarks and providing overview of Nepal Geotechnical Society. So now I would like to request Dr. Anil Joseph, ISSMG VP Asia elect and President of AGSSA and Indian Geotechnical Society for his opening remarks. Over to you, Dr. Joseph.
Very good evening, all of you. It's a proud privilege for me to be here, and we have a network of good friends across the world here. First of all, I would like to acknowledge the presence of 𝐒𝐞𝐫𝐢𝐞𝐬, the Vice President of JGSSA, who is joining from Pakistan, and my very good friend Marwan, taking a lot of initiative, joining from Dubai, and he will be giving a wonderful talk. And Dubai is the place where the world goes to do business. So he has got so much of wonderful stories to tell, which are creating the tallest buildings in the world. So he has got a lot of data to share with. And also we have Mohan Prasad Acharya talking about the pile foundations in Nepal, and my good team of friends from Nepal. I am so happy that they have won our best upcoming society of the world of ISSMGE, and it is very sheer the dynamic strength of the team. Mandeep, Kalpana, Rajan, Indraprastha, so many teams, so much of wonderful friends in Nepal. So it's all like Mark points out, our international president points out, geotechnical engineers without borders. So it's GeoVerb. We are geotechnical engineers without borders. We are connected together to solve the problem of geotechnical engineering, and it all started with Carl Tarsagi starting way back in 1926. So let's unite together and let us share our knowledge, keep our friendship growing. And I congratulate the team led by Mandeep and team, the secretary of the AGSSA, for taking the initiative. He is connecting with one country to the other, so dynamic, and taking the team with the support of his better half, Kalpana, being the general secretary of the team, and the entire team is very dedicated to that. I know there is a lot of people who have joined from UAE also. I am looking for the opportunity to come to UAE to be along with you as soon as the program in Vienna, and I wish all the very best that we will be able to get the next ICSMGE 2030 to Dubai, where Marwan and team will be hosting all of us, and we will have a rocking time together and taking the Asian flag going high. Thank you, and wish all the very best for this particular session. And special thanks to Mohan Prasad Acharya and Dr. Marwan for sharing their valuable knowledge with the team, and wish all the very best for this webinar. And we have a long way to go as our relationships flourish as we move forward. Thank you, and all the very best.
Thank you, Dr. Joseph, for your inspiring and insightful opening remarks as always. So your leadership within AGSSA and IGS has played a pivotal role in strengthening collaboration, knowledge exchange, and professional ties among geotechnical societies across South Asia. So we are also delighted to see you elected to the important role of ISSMG Vice President for Asia, and which reflects your outstanding contribution to our profession. So we look forward to continuing our collaboration not only within the South Asia, but also across the broader Asian geotechnical community as we work together to address common engineering challenges, share knowledge and experiences, and advance our profession through innovation and emerging technologies. So we will now move to the technical session of today's webinar and hear from our distinguished invited speakers. Our first distinguished speaker is Professor Dr. Marwan Al-Jaili. So Professor Dr. Marwan is a professor of practice and innovation leader with more than 24 years of professional experience, spanning advanced geotechnical design, smart construction technologies, and higher education. He currently serves as Senior Manager, Geotechnical Engineering at the Dubai Development Authority (DDA), where he oversees complex geotechnical construction activities and leads strategic initiatives in digital geotechnics, smart city integration, and automated engineering workflows. Dr. Marwan holds several academic appointments, including adjunct faculty at Heriot-Watt University, Dubai, and Abu Dhabi University, and professor of practice at Ziggurat Global Institute of Technology, Barcelona, Spain. He also serves as a visiting professor at the University of Dubai, focusing on postgraduate teaching and research in solid structure interaction and the digital transformation of geotechnical practice. Dr. Marwan earned his PhD in civil engineering from from TU Darmstadt, Germany. With approximately 30 peer-reviewed publications, he serves on the editorial boards of the Indian Geotechnical Journal and the Emirati Journal of Civil Engineering and Applications. Dr. Marwa is a founder, member, and vice president of TFI Middle East, the ISSMG UAE chapter, and the Geotechnical and Materials Engineering Community GOSOE at the Society of Engineers UAE. So the title of his presentation for today is Geotechnical Design and Deep Foundation Challenges for High-Rise Buildings, Case Studies from the UAE. With this introduction, it is my pleasure to invite Professor Marwa to deliver his presentation. The floor is yours, Professor. You'll have approximately 20 to 25 minutes. Thank you.
Yes, thank you. First of all, thank you, Rajan, for the nice introduction as well, Ms. Kalbana, for sure. I would like to thank Dr. Anil Joseph, the VP Asia, and I hope in the next term you will be the president of ISSMG with all the support for you. Dr. Anil, we are looking forward to see you in end of June in Dubai. And we are looking forward to your presentation as well, and also in Riyadh in October. Thank you for this. And the beginning also, I want to say his important role also to create this relationship between Nepal, UAE, India. He's doing really amazing job. Even he need 2 weeks to start his official position, but he's doing a lot of work even before starting his work. So thank you, Dr. Anil, as well, Dr. Mohan, Dr. Suhail as well from Pakistan. It's my pleasure to meet you, Professor, and nice to meet you. And now I will start sharing the screen, if you allow me to share the presentation. I can now?
Yes, you can.
Yeah. It's not allowing me to share. Yeah, now okay. So you can see my screen now?
Yes, the screen is visible.
Visible, huh? It's
Yes,
clear,
it
right?
is visible now. Yes, yes.
Okay. So also congratulations for Nepal Society for being selected as more active, and it is really showing a lot of activities in very short time, as well as I hope you all the best in 2027 in GeoMando, which I hope will be a very great conference as well. So I will start my presentation. Today I'm going to talk about the geotechnical design and deep foundation challenges for the high-rise building. It's a case study or many case studies from the United Arab Emirates. So I will, in this presentation, I will be focusing on research 1, which is related to stiffness and strength of Dubai sedimentary rock. And I'm going to highlight as well a few information about the remaining research 2 and 3 and 4 and 5, which is skin friction or skin friction resistance of pile design using preliminary using PTP in Dubai, as well as the value engineering using load cell test data for Paris Foundation in Dubai. And also, again, we are using the evaluating the UCS values in the weak rock, in the sedimentary rock in Dubai. And the last one related to the empirical and numerical study of static lateral pile response in Dubai, as well in Dubai sedimentary rock. So basically, the first 4 research is focusing in the behavior of the pile, in the vertical and the capacity of the pile itself. And about research 5 is we are talking more about the lateral pile capacity. So we'll start about it. This is I will be sharing with Rajan all the information about publication, and all of them is available for free, where the student and where the researcher in Nepal and in the other places in the world they can use it. So here we'll start with it. In this research, let us talk about it. We We started the agenda. We'll talk about the idea of the research, the study objective, as well as what is the statement, the problem statement of the research, the project location, the geotechnical information. In this research, we test almost 116 piles for different towers in the United Arab Emirates, specifically in Dubai. We'll talk about the analysis methodology. We'll talk about the conventional approaches to calculate the settlement of the pile. Then we will compare it with the FEM modeling, and we will determine the E value of the E-rock, or we call it the models of elasticity of rock. As well as we are talking about the case study, we have a Paramount Tower, and then the conclusion. So always we are talking about the research idea, from where we get this research. Most of the time when we are used to review and we check the project, we find the calculated settlement from the, let us call it empirical and analytical approaches is much high with compared to the settlement which we are finding out from the static load test at the site. So for example, in many cases, we calculate the settlement 15 or 20 millimeters, and actually we found it at the site is not exceeding 5 millimeters. So from there, we decided to start how we can, why we have those all differences between our calculation and the actual values which we are getting from the site. So at the beginning, we decided to go to the objective of our study. Our objective of the study, it's divided to 5 main things: evaluate, perform, investigate, develop, and provide. So first of all, we have to evaluate the soil properties from the geotechnical investigation report. After that, we have to perform a comparison between the pile calculated settlement, between empirical and analytical equations, and numerical FEM models, as well as with a static load test actual settlements which we are getting from the site. After we compare between all these approaches, or the 3 main approaches, we investigate the performance of the single pile on the weak rock and evaluate the young modulus of rock. Then we will develop a comprehensive methodology to analyze and design the single pile in the embedded weak rock or Dubai sedimentary rock, and provide a contribution to the geotechnical engineering field, especially with regards to provide economical foundation design and for the green construction. So here we divided the problem to 3 steps. Underestimating the soil properties, design parameters will lead for sure to over-design. After that, over-design means wastage of concrete, steel, water, time, energy consumption, cost, and a lot of environmental problem. This is what we are saying. It's necessary to optimize our design, which will lead to green construction and positive impact to our built environment. So this is the location in this project, or in this study. We studied 28 projects, more than 40 towers. All this tower located in Business Bay, or where we call it center of Dubai, where we have Burj Khalifa, the tallest building in the world. We had 116 static load tests, and we had 196 boreholes which related to that. Here, this is the map of the United Arab Emirates. Here, what we are talking about, Dubai, the capital of United Arab Emirates, as all of us know, it's Abu Dhabi, and you can see different cities like Sharjah, Ajman, and other cities. So here, the location exactly in Dubai. This is in red. You can see the project where we have it. So we have the project location, which related to, so 28 projects, you can see them in red, and 40 towers. So some project has more than 1 towers, and we have 116 static load tests. Now the geotechnical information. This one. Okay, so the project information. Now we divide the geotechnical information to the type of boreholes itself based on the depth of the borehole. So we have almost 14 boreholes. They are 25-meter depth, 44 boreholes between 25 to 39, and as well as 100 boreholes. It is between 40 to 59. and more than 60, we have 37. In total, we have 195 boreholes. We divided, this is exactly how the soil in Business Bay, we take basically about the northeast side and the west side as well. And here you can see this is, we call it the general geotechnical profile. We have at the top 5-6 meter sand, then we have sandstone, then we have siltstone. This is cross section which representing the Business Bay. Now, this is the parameters basically based on the geotechnical investigation report. We have the sand in the top 5, as we mentioned, 5 to 8 meters, and as well as Dubai sandstone and Dubai siltstone. Now, the static load test, you could see we are collecting most of the time all this data. At the beginning, some of them we have all data, which is we use Q-Tnh beam, and some of them we are with reaction beam, as you can see in the picture. Now here we divide them to PTP. We had 2 of them. Instrumented, we have 2 piles, and working piles, which we have the major of our study. Now this is because this study started from 2012. Now mostly we don't allow the Q-Tnh system anymore due to safety. And you can see the Q-Tnh system at that time, we have more than 50%, and reaction beam frame, we have around 48 or 47%. Now we are talking about the analysis, how our process, the framework. Now, simply we divide this to certain steps. So step 1, we have to first of all compare the pile settlement based on the static load test result, and as well as based on the soil report. So our step 1, we will calculate the settlement. We have empirical approaches which are famous here. We have Bowles, Tomlinson, and Das. And with the same parameters, we will use the numerical method. We use Blacksys, and we did verification with my Das GTS. And here we have, as you can see, we have as well as the empirical, the experimental test, which is static load test. We will compare between the 3, and after that, we will compare between the empirical analytical method, FEM method, and static load test. Now, accordingly, as I mentioned at the beginning, we have a big gap between the settlement from the static load test and our empirical calculation. So we keep change the value of E, or we keep change the value of E and C, the geotechnical parameters, until we fix or try to reach to the same level of settlement, which we are getting it from the static load test. So we will assume the value of E, keep changing the E in the geotechnical model, in the Blacksys, increase it until we fit both curves, and we found the actual E, which we call it modified E of soil, which is in this case AE mode. And after that, when we get the E mode, we will use the new E in our calculation, either in the finite element, and even though in our empirical equation, and after that we recommend the modulus of elasticity. Now, the back calculated E, because in many sites we don't have one test. We have, as you will see now, in some sites you will have 5 or 6 tests. So in each test you will get a different E. In this case, you have to compare between them, and you have to recommend one of them. Basically, we go for the minimum, and you will see what exactly we do. Here you can see the settlement. I will go very fast in this part, which is related to the settlement calculation. Here you can see mainly the settlement of the pile divided to 3 types of settlement. We have the elastic shortening of the pile. We have the pile's base settlement, displacement due to the tip, as well as we have the shaft. This is shaft displacement, which is related to the skin friction. You can see here the equation from Das approach, where he divided also to 3, and he had a few things which related to the, we call it factors, which you should use it based on the behavior of loading of the piles. As well as here we have Bowles and Tomlinson, and we rely on these 3 methods. There are many methods, but we rely on them because they are widely used in our industry, geotechnical industry design market. Now determination, now we'll start one by one. This is the first pile. Exactly, we have the pile length is 23 and the diameter is 0.8. This is the load 7,700 kilonewton. The test load usually will be 1.5 multiplied by the working load. So it is 11,500, and this is the E of concrete, and this is the length. Now here you can see the soil profile, and here you can see the parameters provided from the soil investigation report, and what exactly the E value based on that. So moving forward, yeah. Now we have the static load test. You can see from the static load test, this pile only moved 4.4 millimeter for 150% of the load for the test load, and for the working load is only 2.5 millimeters. So you can see how it is very difficult, and how you'll see the difference between the calculated empirical settlement and as well as the static load test. Now here the curve you can see. The first method, we rely on dust. You can see up to the working load, the settlement is almost more than 10 millimeter, and after that, it went dramatically to very high value. The second one is related to bowls, and here you can see also for 100% it's reaching even 30 millimeter. Here for Tomlinson, it's something like 15 or 11, and here you can see the finite element. Now, the important thing related to the blacks is here, we use it with the parameters from the soil report. So we still use a very low E value for the Dubai sedimentary rock. That's why you can see the behavior of even the finite element is very close to the empirical behavior. Now, the surprise will be with the static load test. Now, the static load test, you see how much the difference? And even though if you take the working load, still there is a big gap between the static load test and the empirical and the FEM model. So what our work in this research for 116 piles, we should back calculate the value of E using the Black's until we fix that, until we fit that curve, the Black's curve, with the static load test. Now here you can see we are trying to find, so this is the same one, FEM model from the parameters from the soil report. This is the static load test, and here we have now the FEM back calculated. Now the surprise will be here, you can see here, the E value used previously in the black line here, you can see it was 60, the value of E, which we get it from the geotechnical investigation report. The back calculated one was 5,083 times the value which we are assuming it in our design. And you can see here in the second part, we have 100, and after that, the back calculated, it is 5,000 again, but no load transfer in the two layers below. As you can see at the beginning, the length of the pile is 23 meter, which is not penetrating to the lower values. Now, here, this is the point. It is, our E is very low. So basically, what we should do, we should use this E in our empirical equations. Now, this is the static load test, fitting 100% with our back calculated Black's model, but still, we have some problems with related to the empirical equations. So still there is a gap. So this is lead to investigate more why this gap is there, and we found out the reason here. Because as I explained at the beginning in the theoretical part, the settlement of the pile is divided to three main components, and one of the important component here, we have it, the elastic shortening. Here from the Black's model, you could see the load is not transferring at all to the lower part of the pile. That means the effective length of the pile is only 9 meters. So when you go back to the equation here, sorry, I have to go back very fast just to put you in the same picture. So here in the elastic shortening, this L, when you use it 23, it is not the right value because you have 13 meters are not impacted in the load. So that settlement value for the elastic shortening, the first part, will be totally different. So when you go back to our calculations, sorry, I'll go back again here. Yeah, so our effective length, when we do the calculation with 100 working load, will be 9 meters only. And in 150, from the working load, it will be 11 meter. So when we back calculate the settlement, now all the curves are fitting 100%. So you could see now, even though the settlement from DAS method is matching 100% with the static load test and with the Blacksys model, as well as the Tomlinson, and the same thing also BAWS. So all of them now are matching 100%. Now, to do verification all the time, we did all this research on Blacksys, but we decided to go and to double check our result using the MIDAS GTS NX, and we found them are fitting 100%. Now, to continue, just to give a small explanation how basically the empirical calculation for the models of soil usually used by a lot of geotechnical lab and based on empirical, they're relying on Tomlinson models of elasticity calculation, which we rely on J and MR and QUS. J is a mass factor relying on RQD of the soil and wave velocity, as well as the soil classification and the laboratory. Now here you could see it's very simple. You can see in the sorry, to highlight a few things. The RQD, there are huge human factor in the RQD, because this is related to the quality of the work of the geotechnical lab. That's why the RQD sometime, because of the J, we go sometime to 0.2, which reducing 80% of the E-value of the models of elasticity of the rock. That's why, relying on this equation, the human factor is quite high on it. Here you could see, and this is what exactly we are talking about, the RQD. You could see you cannot understand anything from the RQD, and all the time is pushing you to go to the lower values. And here you can see our UCS value is not exceeding only the 5 UCS, the value. Now here, just a small comparison. This is the E value based on the soil report. You can see it here, okay? And you can see the values. We have 8 piles, the E value between 40 to 60, 35 piles, we have points, let me call it not piles, call it points where the pile located. And also we have 70 to 80 and also. Now the surprising things, you can see it here, the back calculated value, the minimum value, we have it here, it is almost 1,000 or 900. And you can see, even though in some points we reach up to 10,000 MPa for the models of elasticity. So this is the E back calculated, where you can see it here in the back calculation for the 116 piles. Now the case study, this is the project location in Dubai. Just if you confirm, you can see the video working. Rajan, if you could confirm.
Yeah, it is working. Yeah, it is working.
It's working, yeah, perfectly. So this is when the project location, when you visit Dubai, you'll see it, you call it the Paramount Towers. There are 4 main towers. It's a 5-star hotels, one of the big hotels here. And it's already constructed and completed and operated for a few years. You can see it is almost 75 floors. The height of the towers is 268 meters. We have mainly the information, the geotechnical information. Now we will have most of it related to the piling construction. This is the piling, yes, here. Let me stop here a little bit. We have almost 618 total number of piles, 2 PTP tests, 6 static load tests, 32 dynamic tests. We have 63 sonic pile load tests, and we did 31 durability pile tests and 4-meter maximum pile length. So the pile length reach up to 44 meters. And here you can, this is the load which you reached mostly 23,225 kilonewton. And let's continue. This is some picture related to the site during constructing, during the geotechnical work. They have you can see the shoring systems as well as you have it. And this is the building during the construction. And as I mentioned, this building is already completed. So It is 268. It's quite high tower, and we had also we calculated also the settlement of the foundation of the building as well during construction. So this is related to the video. We'll move then to the next slide. So this is the profile which you can see. Now this is the profile here. The additional things which we have it, we have some conglomerate here, which is also part of, we can classify it as Dubai sedimentary rock, as well as you can see our normal and classical soil, siltstone, sandstone, and sand, where you can see it. Here the 3D which showing the UCS values. And here again, this is the same piles which I explained at the beginning. And this is, you can see 83 piles. So in this site, we had, as I mentioned, 6 piles. And you can see in all those piles here. So for the second pile, you can see to back calculate the value and to fit the curve between the FEM model and the static load test, we have to increase the E value to reach 3000 megapascal, which is 50 times the original value which we are using it from the soil report. It doesn't mean that the soil report value at the beginning is right, but this is what we want to highlight with respect sometimes using the empirical approaches in the geotechnical investigation report. Here you could see in the second pile we reach up to 70 times. Here you can see we reach up to 45 times. In the pile number 75, we reach up to 24 times. And the last pile, we reach up to 33 times, which is 2000 MPa. So simply, as I mentioned at the beginning, we decided to check how much the settlement, which related to the building itself. And at that time, when we complete the structural skeleton, the settlement of the foundation is only 14. And we try to calculate the total settlement of the whole and back calculate the E. We found that the E back calculated, which is related to the whole structure, is almost like 1,540. So if we take this study now, the modulus of elasticity back calculated, we took the minimum, even though we reach in some, you could see in some piles we use up to 5,000, but said we will not go for the 5,000. We will go for the 1,450, the minimum value, which is related to the back calculated E modulus of the Dubai sedimentary rock. It is still 24 times more than the soil design values. The pile numbers is 618 piles. If we take the diameter is 1.2, this is the length, the total length of piles is almost 20 kilometers. And the total volume is 22,104 meter cube. Now, if we said, okay, we can minimum save roughly 10 kilometers of concrete, and just if we putting some effort in numerical modeling, try to do more investigation, like in-situ tests, like pressure meters for sure, and other type of tests, which for sure will lead to much higher value for Dubai sedimentary rock or for the weak rock or intermediate material in general. So the conclusion of our research is all the time relying on soil parameters and relying on empirical approaches. This is for sure we will lead to underestimating the pile design, and for sure we will have a very huge gap between the static load test and the actual settlement calculated value. Now the FEM back calculated shows effective method, and you can see we can reach up to 20 times or sometimes 10 times the E value which obtained from the soil investigation report and the empirical approaches. Here we can use the E value, and the problem is not using the settlement calculation is empirical or FEM on this one. The main problem is more related to the E mode. And you have to be careful while you are using the equations with the effective length of the pile itself, where you should calculate the elastic shortening calculation or elastic shortening settlement, which is part one of the settlement of the piles. Now, the numerical analysis technique based on finite element shows an accurate estimation and expected settlement value under the static load test. Okay, and for sure relying on let us say the soil report in general, or relying on the empirical approaches such as Tomlinson equation, for sure will lead to an economical design. And here, for example, relying on the back analysis, trying to rely on pressure meter, try on in-situ test, for sure will lead to economical design of the pile foundation. Minimum modulus of elasticity for the 116 piles was almost, for the case study, 1,450. For the whole study was almost 1,000 MPa. The settlement of the whole buildings was 15 millimeter, where maybe we have margin up to 50 millimeters, according to the limitation provided from the structure engineer. Based on the research, still we can do a major saving for our surrounding resources, such as concrete, steel, energy, and cost, as well time, and a lot of resources. Now, I conclude the first case. Just I will give a small information about these researches, and also shows a lot of saving which related to the pile design. And you can even, I will share, as I mentioned, with Rajan all this, and he will email it, inshallah, to all of you. Now, this one of the researches was done by my colleague Benoit and myself, and also Rian, Michel, and as well Joy, and we did all these researches related to, in this research, sorry, back, if we go back, in this one, we simulate the O-cell test itself, not the static load test. So we found out, even though a very good result. Here we compare the parrots. Here you can see my good colleague and friend, Professor Dipankar Chaudhary, and as well as Dr. Sujata Manoj, one of PhD scholars and PhD graduate from IIT Bombay, and myself here, as well as with Sujata and Dipankar. And here we have also the chance to work with Professor Harry Poulis from Australia. And here we back calculate the UCS value itself. And in the last research here, we said, okay, let us try to calculate the E in the lateral direction, and we found it is very close to the vertical one. And even though we reach up to 1,000 MPa, in this research, we work with the head of civil engineering department in Abu Dhabi University, Professor Amar Maghaida, as well as with Dr. 𝐒𝐞𝐫 from Abu Dhabi University, myself, Dr. Ramesh as well from Amit University, and also our colleague and PhD student at IIT Dhanbad, engineer Akash Sharma. So thank you, and we can, if you have any question related to that, you can ask me. Thank you for listening.
Yeah, thank you, Professor Marwar, for your insightful and informative presentation. So I'm sure the audience has gained valuable insights from the UAE's experience in deep foundation design and construction from your research. So we will take questions during the Q&A session shortly. So after completing the next presentation as well. So participants are kindly requested to put their questions through the Q&A box. Thank you, Professor Marwan, once again. So from the UAE experience, we now shift our focus to Nepal, where deep foundation construction presents its own unique challenges due to soft valley soils and complex alluvial river deposits. So our second distinguished speaker is Dr. Mohan Prasad Acharya from Nepal. Dr. Acharya holds a PhD in geotechnical engineering from the University of Alberta, Canada, and an MSc from Pulcho campus, Tribhuvan University. With extensive experience in geotechnical engineering, he has contributed to the design of over 300 bridge foundations, large hydropower projects, and seismic guidelines for dam design and renovation of damaged hydropower projects, and risk and hazard analysis. So his expertise includes slope and tunnel stability, deep foundation settlement, construction at complex ground conditions, and design for risk reduction and hazard mitigation in hydropower projects. He's also serving as Vice President of Nepal Geotechnical Society. The topic of his presentation is construction practices of deep foundation excavation in soft valley soils and alluvial deposits of mountain rivers in Nepal. So with this introductory note, I would now like to pass the floor to Dr. Acharya sir for his presentation. Over to you, sir. You have also about 20 minutes for your presentation.
Okay, Rajan, thank you very much. That's already too much for me, too much about me. And I'd like to thank Dr. Marwan for his very insightful presentation, very detailed and lots of information. Today, I'm going to present, as Rajan said, I am going to present some work on the design and construction practices in deep foundation excavation in Nepal. So can you please tell me, you can see my presentation? It's visible now?
Yes, sir. It's
okay. Thank you.
You can just start the slideshow, sir. Okay. Okay.
Okay, let me start. The urban construction in Kathmandu Valley is comparatively small than that just Dr. Marwan described in UAE. Still, because of the lack of the land and the public areas, the high-rise construction with multiple basement level is being common in Kathmandu as well. That's why we need the deep foundation construction. It's now unavoidable. And similar to the buildings in highways, new bridges are being built very in the close proximity of very old bridge foundations, and those foundations also have to be protected and supported during the construction. And similarly, we are like in the boom of hydropower productions, and several power stations are being planned in deep into the alluvial deposits, and those power station need large excavation and support. The deep excavation technology in Nepal, I would say, is in the very basic stage. I have some examples of deep excavation work and some lesson learned. I'll go into the presentation. Okay, if the chart is visible, that shows the number of buildings by story height ranges in Kathmandu Valley. It's growing like in last 20 years. I think there were none, and now like we have at least around 50 buildings already above 10-story, and half of them should be above 20 or near 20-story buildings. And those buildings, out of those buildings, 50% have the double basement excavation. Double basement, that means which needs about 10 to 12 meter of deep excavation in very soft soil of Kathmandu Valley. So you can see, if you can see the borehole log, and this is the typical borehole log of the Kathmandu Valley. That's it consists of intermittent layer of medium to fine sand and soft to very lightly stiff clay silt. You can see with the very low SPT value, most of the time around about 5, and most like a very few times near 10. And due to that, the soil has very low bearing capacity, and sand layers are liquefiable during cyclic loading. And the foundation types usually like planned are for 5 to 10 stories, mostly rough and above 20 meters. 10-story buildings, mostly rough and sometimes with piles. And the most important factor during the construction of these basement and like deep excavation is the soil not only liquefiable during cyclic loading, it's also like highly susceptible to cyclic mobility during the excavation. At that time, there will be the progressive strength loss due to separation of soil particles and water at low permeable media. That will increase the pore pressure during the construction loading, and that's mostly like a vibratory in nature. I have some examples of the deep excavation in Kathmandu, and one of them is a 16-story building in the mid of the Kathmandu Valley. It has a double basement, so the maximum depth of excavation is around 11 meter. And it has the pile draft planned foundation. The length of the pile is near 30 meter. And the soil strata in the whole area is not uniform. At the very southeast corner, as you can see here, that has the very thick layer of very soft clay with water content near 50%, and sometimes with it has the organic content as well. And at that point, like the deep excavation was planned with pile that of about 0.8 meter diameter and 20 meter deep, and several layers of nails were also designed and constructed accordingly. You can see the pile during the construction and the soil nail during the excavation. One important thing to note here is like the excavated surface is already muddy. It's like a muddy, I will say muddy soup. And not all the part has that, but you can see in that Google Earth image of the same time, at the not in the north is dry, and the southwest is also mostly dry. But at the corner, at the southeast corner, you can see the very wet. Maybe the water is like a few 5 to 10 centimeter of water is on the top of it. And one more thing to notice is the support is already rounded. That means large deformation was already occurred there. And in the next day, in a couple of days, we can the 6-story building and a couple of like very old traditional masonry buildings were collapsed, not completely collapsed, but they subsided by 4 to 5 meters. And at the time of the failure, there was excavation was going on with the 4 to 5 excavators, and several trucks were transporting the excavated material. And now, after all, the building is near completion after removal of these like damaged buildings and inclusion of the area as well. And the next one example is the excavation of the like basement for the one of the like hotel building. I think I can see the top part. Hotel building in Ravi Bhavan, Kathmandu, also in a like deep soft soil deposit. The maximum depth of excavation was 9 meter, but the critical thing is the nearby buildings are very near, at the like within a 1 meter of the boundary of the excavation, and that's the most critical part. So we started with the design part, and as we can expect, below 5 meter, the soil strata is very soft, clay silt of medium plasticity. That was like confirmed with the trial pit excavations, that the excavator it's very difficult to go below the 5 meter depth. And we can see at up to 5 meter, the soil itself is standing vertically with a 1 to 2 meter bends, no issue. But just after lowering below 5 meter, the mud soup is already formed, and the excavator, it's difficult to movement of the excavator as well. And the more like important thing is that also the soup formation traveled even beneath the unexcavated part, and that resulted the failure of the unsupported wall. So with that experience, we moved to the design of the support system for the person where no buildings were there. We simply use the 2-inch dia, 6 meter long pipe pile below at 0.4 meter center to center and supported by the struts. And that worked well for the 7 meter excavation without surcharge. But one most important thing is no excavator was allowed below the 5.5 meter depth. And beside the large building structure, seat piles are like introduced. I think this is the first time that any building excavation has used the seat piles in Kathmandu Valley. Those seed piles were jet-type seed piles of section with a section modulus of about 2,000 centimeter cube, and they were placed 10 meter long and also planned to be supported laterally with the struts. And that's the excavation is completed at that part and without any difficulties. At the very narrow area where no removal of the seed pile is possible, that 0.4 meter diaboard piles up to depth of 14 meter were planned, and the spacing of 0.5 meters center to center. And the struts are also placed of ISMB 350 at 3 levels. And again, during the construction of the piles, no machine is used to drive the piles. And the excavation and the support work is coming up without a big problem. And similarly in the construction of highways, this is one of the 700 long bridge in the eastern part of the Nepal. A huge new bridge is planned to parallel to the almost 50 years old bridge at just 4 meters away. And for that, and next thing is for the new bridge, the pile foundations was designed at about 5 to 10 meter deep. So there should be a 12 meter by 20 meter wide trench has to be excavated to a very old bridge foundations. So for that, the struts breast excavation is planned, and the seed piles IS section 1021 and 1481 were planned, and then the excavation was made accordingly. And we have the pictures of that. Though the groundwater table is very, very near to the surface, the excavation and construction was done without any difficulties. And one important thing here is the soft soil. The soil over there was a matrix of boulder, gravel, and sand, and no clay, no silt as in the Kathmandu Valley. Similarly, deep excavation these days is also being used in the hydropower sites. 20 meter, this is the picture of the 20 meter wide power plant in the middle of the Pokhara. We know the Pokhara has a deep, very thick sediment deposit. And the ground layer at the foundation at the power station consists of alluvial and colluvial content of different sizes of material, mostly fines. And the intermediate fines might be compressible. That was the expected complexity. And the power plant was designed by Clean Energy Consultant, has the excavation depth of about 16 meters below the ground level. But though expected, and we can see the very stiff cliff of around the Pokhara Valley, we can see that during excavation. For almost 6 meter vertical steps where we found stable, and so there was some erosion during the summer season due to the rainfall, and sometimes the excavation trench was full of the water. Still, there was no imminent failure, and not a big chunk of slide occurred, and the excavation and the construction was continued without any complexity. We can see the completed structure from inside and already placement of the turbines and other machines. Another small powerhouse was excavated to the almost 20 meter deep in the riverbed of the boulder mixed soil, and it's a boulder mixed soil. And we found that, and the lesson learned is the densely compacted boulder mixed soil with sand. And can we can see stand up to 4 or 5 meters without any support. Though the construction practice is not standard, but they managed to quickly get the base of the powerhouse up, and then now already the zero wall is being constructed. Another big and very challenging work was designed by an engineering company for the Sunkosi Marine, one of the big diversion project in the southern part of the Nepal, where the bedrock is mud stone, and on top of that, around 50 to 60 meter thick sedimentary soil layer exists. exist. We can see this is the source tank and this is the powerhouse, and this 26-meter diameter big structure has to be built on top of the within 40 to 50 meter thick soil strata. And this is the more like close view of the plan of the source shaft. And it was designed, it was like in section, this is like that, and this is designed to be built with the placement of the second pile around the 26-meter dia source tank. And this surface excavation is planned because of the, as you can see that the soil is as low as 40 meter below the top of the surface of the land at 480 and 446 meter. Below that is the Mount Stone over there. So the plan is to build the foundation at the Mount Stone at the lowest level, and to place the second pile around the source tank, and excavate all the way to down and build the concrete structure in the middle. And this is the planning, not exact of the for the project. The pile has to go around the diameter of the source tank, and the wind going down to the excavation. The pile has to be supported with a circular beam like that. And this was in fact like inspired from the work in some part of the Europe where near surface train stations were excavated and constructed like that. That we get. But the part of it is just being started and no construction is being done yet. So we have to wait for its performance. So I don't have much, so I'll go for the conclusion. Though the deep excavation construction is more recent, it's growing very rapidly in Nepal. The deep excavation in Kathmandu is complex due to the soft soil strata at the excavation level. And next is the proximity of the neighboring structures, and mostly they are very old. And next, the groundwater tables and soil saturation levels are the critical parameters. A gradual rise in pore pressure within the impermeable fine materials during excavation progressively reduces the soil shear strength, increasing the risks of the structural failure and subsidence that we noticed and happen in Kathmandu. And thus, strict adherence to the sequential construction and excavation methodology is mandatory to maintain the stability. And deep excavation is notably less challenging in layered and slightly consolidated soil that we saw from the example of the Pokhara, where multi-meter vertical benches can remain stable. And surprisingly, in the highly dense alluvial boulder mix soils, the deep excavation is still less challenging, but maybe that heavily dependent on the material gradation. And I'll say at the end, the local expertise and engineering competence in deep excavation methodologies are steadily increasing, and we are learning more and more. Thank you very much.
Yeah, thank you very much, Dr. Acharya sir, for sharing your valuable experiences and technical insights from Nepal. And so your presentation has provided an excellent perspective on the practical challenges and solutions associated with deep foundation construction in diverse geological settings like in Nepal. So we'll now move to the Q&A session. I think we have received a few of the comments or like queries in the chat box. So we will start from there. So we will spend a few minutes for the Q&A session. So, Dr. Marwan, did you get time to go through the comments, or can you please explain in a few minutes?
Yeah, no problem. But where I can't find questions, chat box.
Yeah, chat box. Yeah. So
Okay.
I can help you with the question.
So
So
I
first
think
of all, we have a question from 𝐶𝐞𝐫𝐢𝐞𝐬, sir, from Pakistan.
yes.
So he's asking single pile versus actual pile group settlement.
Yeah. So
And yeah, he
he's
has a few more questions as well. Like, Second is why pile load tests were not instrumented, as that would have given a better estimate of load transfer. And third one is your comments on the fact that UCS results only depict hard rips in rock, not rock mass.
Okay, so I will start with the first one related to single pile and actual pile group settlement. Yes, I totally agree. There is a big difference between the two, and while we're designing our foundation, we should rely on the pile group settlement. Our research is focusing about the back calculation of E value. So regardless it is for group or for single pile, it is just we are estimating back calculating the E value. So for sure, when you design your foundation, you should rely on the pile group effect, and the pile stiffness should rely on the pile stiffness due to the load, and you can obtain that from many numerical software such as Blacksys and Meidas and other softwares. And for single pile, it's just to make sure that the single pile stiffness within the limits. Yeah. The second one, it is why the load tests were not instrumented. No, we have many instrumented piles. We have 2 or 3. And we also compare it, but the point is, which I didn't explain it much about the modeling itself. We model the pile as a volume element. When you model the pile as a volume element, so it will mainly be controlled by E and C, and the rock was the soil model was Mohr column. So we don't have any input with respect to the FS and as well as the skin friction and the end bearing. Maybe in the second research, which we simulate the PTP or the preliminary test pile, yes, in that one we use embedded pile model, and in this case we can back calculate as well the skin friction. So Dr. Suhail is there, so you can add any question if you want. So basically this one, because we use 2D axisymmetric volume, so we only the parameters which we keep changing it is E and C, so we don't rely on the skin friction, but we compare it as well with the skin friction as the outcome, and we found the values are very close. Yeah. So this is regarding the question 2. The third one is I think this is from Mubashir Aziz, right, Rajan? The next one. A quick tips for settlement calculation for a clip.
Yeah.
Okay. With combination of the Pareto piles. See, my opinion, the right way to do it is using FEM numerical model, geotechnical model to calculate it. Because there are few quick way to calculate the pile stiffness, not the group settlement by impairing, also the group settlement as well. But in my opinion, in case you have mixed foundation between the pile and the pellets, it's better to use the FEM model and to calculate specifically the group settlement as well as the pile stiffness and the pellet stiffness, and then you can use those stiffnesses on designing the raft foundation. Yeah, the next one.
Yeah, and there's
This
another
is
from
from
Muhammad
Rajan.
Fatih.
Muhammad Fatih. No,
So
there is
there's a
also
question.
from Dr. Suhail. Your comments on the fact UCS result is only the rock and not the rock mass. See, my opinion, because the nature of the material, the nature of our material, like Dubai cement, was very fractured rock. So the human impact is very high. And for example, if you are not, when you do, for example, the RQD or try to take the sample from the site, if you are not doing the proper segment or reduce the segments, will have very impact in your RQD. And when you use the equation with related to Tomlinson, which is we have J factor, the J factor is highly impacted with the RQD. So because of that, we said all the time, you found in the same level UCS value sometimes very high, UCS value is low because of the nature of the fracture material, as well as the RQD. In some places, in some soil report, you will find it very high, in some reports is low. So this is the human factor, which in my opinion is impacting. Solution of this, even if you don't want to do pile back analysis, in my opinion, you should go for geophysical test, which is very useful. You can like shear wave velocity, you can go for pressure meter, the latometer. Those will give you in situ and much higher values of E, which is comparable to the values which back calculated from the single pile analysis. Yeah. So the next one.
Yeah, Dr. Marwan, maybe, yeah. I think we
Enough?
will collect all the questions from here
Yeah.
and send to you
Okay.
and send back the
I will send the email. Yeah.
response from
Okay.
you. So
Yes,
this
sir.
one question from for Dr. Mohan as well. Maybe, yeah, maybe Sohail is referring to Mohan, sir. So kindly let us know whether tie-back anchors or internal struts were also considered. You're mute, sir.
Okay. So you mean Dr. Sohail, right?
Yes, yeah.
Okay. For the case of the building, no tieback was allowed because there is no room behind the excavation. For the bridge foundation, it might be possible, but because of the depth of the excavation is limited to 10 meter and bridge excavation was considered enough, no tieback is used.
Yeah, okay, sure. And there's one last for you. For the deep excavation of the salt tank at the Sunkosi Marine Diversion Project, what is the recommended embedment depth of the second pile wall below the final excavation level?
It was considered about 10 meter. The mount stone started at 445, I guess, and the end of the pile was 435 meter. And as I shown in the picture, we were using the ring beam at 3 meters center to center, and that was considered enough steep, and we don't need to go deep into the bedrock because they are not freestanding pile.
Okay. Thanks to both speakers. So we now moved forward. So we will consolidate all the questions and share them with our speakers for discussions and response back to the participants. Now moving forward, I would like to invite Dr. Mandeep Subedi, Chair of GeoMinder 2027, an international conference series of Nepal Geotechnical Society. And Dr. Subedi is also the immediate past president of Nepal Geotechnical Society. Mandeep, sir, over to you. You have about 5 minutes for your talk.
Okay, thank you, Rajan. Respected Professor Indra Prasad Acharya, President Nepal Geotech Society, Dr. Anil Joseph, newly elected Vice President of ISSMGE and President of AGSSA and Indian Geotech Society, Engineer 𝐂𝐸𝐴𝐬𝐬, our Vice President of AGSSA, and he's from Pakistan. And today's resource person, Professor Dr. Marwan and Dr. Mohan. All the participants and my colleagues. The main objective of this presentation is to warmly invite engineers and the colleagues from across the globe to participate in GeoMinder 2027, which is going to organize along with the 11th AYGC and the first South Asian Conference of Geotechnics. Professor Marwan, I sincerely request your support in encouraging participants from UAE and also the wider region. We are committed to making every participant's experience meaningful and rewarding in Nepal. And I also, thank you, sir. And I also extend invitation to all of you here to join GeoMinder and kindly request you to recommend it within your professional networks. With that, I would like to proceed to my brief presentation. I will not make it long. This time we are organizing 𝐿𝐶 2027. This is the third session of 𝐿𝐶, which is 𝐿𝐶 is the conference that is organized in Nepal. It's in every 2 years period, and this time it is going to be organized with the Asian Young Geotechnical Engineering Conference and first South Asian Conference of Geotechnics. South Asian Conference of Geotechnics is the conference of the association we have formed between the South Asian countries of which are affiliated to ISSMG. Okay, Mo. Why to come to 𝐿𝐶 2027 and 11th AYGC and first SAG? Actually, this is one of the largest engineering conference of Nepal. There are we are targeting more than 500 participants in the conference with more than 200 papers. People participate from more than 30 countries. And for the industry exhibition, I think we target for more than 40 industries. And there we will have the excursion tours, reception dinners, AYGC dinners, a SAG special dinner, gala dinner, cultural programs, and it will be very, very happening and a good program along with the technical sessions. Till date, we have obtained 148 abstracts. You know, we have a target of 200 papers, but till date we have obtained 148 abstracts and 25 full papers. And we are extending our paper submission date to May, but we will also extend it to July also, because we will go to Vienna and also ask people to join the upcoming 𝐿𝐶. And till date, most of the papers are from South Asia, 110 papers, from the East Asia, 25 papers, from Western Australia, Germany, Finland, 7 papers, from American countries, USA and Peru, 3 papers, from UAE and Tajikistan, 3 papers. And as per the title of paper, we have the most of the papers are from slope engineering, geohazard foundation, and like this. So we can have the different session with the different paternity of the geotechnical engineering. For AYGC, we have target among the 27 countries of Asian ISSMG country of the Asian countries. We are expecting 20 countries will participate here, but till date we have only 13 country societies have submitted the paper, and we are still requesting it. And the special thing is, this year we are also organizing the LARAM course. The LARAM course is Landside Risk Assessment and Mitigation course. It is an international advanced training program developed by Italy, primarily coordinated by the University of Salerno. This course will be the pre-conference event of 𝐿𝐶. It will be organized from 10 to 16 March 2027. And University of Salerno, Tribhuvan University, IIT Indore, and 𝐒𝐞𝐫 University will be the partners of this training. So I request and also invite the young researchers to be the part of this course also. And this is also one of the attractions for 𝐿𝐶. And Nepal is so beautiful. You can have the place from 60 meters sea level to 1,848 kilometers. So behind the lectures, behind the science, you can also have a good time here to see the jungles, to see the jungle safari, to see the mountains, to see the lakes, Himalayas, rafting, etc. We have many old heritage sites. You can enjoy the old heritage site with the beautiful mountains, mountain flights, etc. And to look back to the previous 𝐿𝐶, the first 𝐿𝐶 we had almost 300 participants and 30 delegates from the international, beyond the Nepal, international delegates. For 𝐿𝐶 2027, we have the participants more than 500, and among them 150 were international delegates from 22 countries, and we had These are some of the photos, and we have the proceedings in a single 𝐿 2024. We had published 4 volumes of proceedings in that conference. So it is the good opportunity to publish for the publication for the researchers also. And these are some exciting moment photo of the gala dinner. And thank you. And please go through Geomandu website and register there, submit your paper, and also suggest your friends. Thank you very much.
Yeah, thank you very much, Dr. Subedi, for your valuable remarks with highlights of Geomandu 2027, 11th UIZEC, and first SCCZ. So before we conclude, I would like to express my sincere gratitude to our distinguished speakers of today's webinar, Professor Dr. Marwan Al-Jaili from UAE and Dr. Mohan Prasad Acharya from Nepal for their excellent presentation and valuable insights. I would also like to thank Dr. 𝐂𝐨𝐧𝐭, Engineer 𝐒𝐞𝐫𝐢𝐞𝐬, Engineer Kalpana Adhikari, Dr. Subedi, the team of NGS and ISSMZ UAE chapter, and our own friendly societies, India, Pakistan, and all participants from around the world for making this webinar a success. Thank you all for your time, participation, and continued support. We now would like to request.
May I say a couple of words before you conclude?
Sure, sir. Sorry. Yeah.
Thank you very much. This is 𝐒𝐞𝐫𝐢𝐞𝐬, Vice President of AAG SSA Forum. I heard with a lot of interest both the presentations. Both were very good, and they explained the local practices, which would be of high value for the engineers listening from the other regions. I would particularly congratulate Dr. Marwan, and I've been very happy to see him around because I have read about the intent and the good wishes of the Dubai chapter of ISSMGE to make a proposal for hosting the next, I think, 22nd International Conference on Geotechnical Engineering, because this is the same reason. So that makes good news a happy news. And so far as this tradition is concerned, that Nepal Geotech Society joining hands with the Dubai ISSMGE chapter, this kind of cooperation for the dissemination of knowledge should continue. Very good tradition set by you guys. Thank you very much.
Thank you.
Thank you, Sohail sir, for your positive and energizing words towards us. And we together want to collaborate and discuss on our common issues and challenges and solve cooperatively. So now I would like to request Professor Dr. Marwan, Vice President of ISSMZ UAE Member Society and 𝐶IO SOE, to conclude the program with brief introduction to the chapter and with closing remarks. This is your host, Razan, signing off. Bye. Thank you.
Yeah. Thank you. Thank you so much, Engineer Rajan. First of all, Dr. Sohail, I would like to thank you for putting and give the information that UAE and Dubai, we are bidding for hosting 2030 ISSMG conference. For sure, this will be hosted by not only Dubai, it's Dubai and South Asia, Pakistan, Nepal, India, Sri Lanka, because those are the closest region for us, which will work together for sure to make this conference successful. I hope in Vienna, all of you will see you there, and I hope we can host that conference as well as in Asia with Dr. Anil, for sure, the VP as well. We need from him the full support. As you know, we never have this conference in that area at all within the all 21 past conferences before. For us, I would like to thank all of you. We have very soon conference here in Dubai in 23rd of June. I will send all the information through Rajan, and I will send, it will be all of you. You are welcome to attend it. Will be in Dubai. We call it Deep Foundation and Underground Infrastructure. In Riyadh, we will have in October, we'll send you IGIC, International Geotechnical Innovation Conference. Also, this conferences will be sent it to all of you. We'll have it in Saudi Arabia and Riyadh. most of you are welcome, and any support from our side, we are open to that. I already even put my email in the chat box, and specifically will send all the information about the two conferences through Rajan. Thank you so much. Thank you all for giving this chance. I hope we'll have you all physically visiting us there in the United Arab Emirates and in Dubai, and have a look in our projects, and instead of doing it virtually, we'll do an actual workshop all together with respect to all South Asia country and all the countries with very close to us. Thank you all. Thank you.
Thank you. Yes.
Thank you, Professor Marwan, and best wishes for the 22nd ICSMC. And it was really thank you, Suhail sir. Thank you.
And see you in Vienna.
Thanks a lot. I'm equally grateful.
Thank you, sir. Yeah.
Thank you, Mohan.